So, hello everyone, and welcome to our virtual workshop today. We're going to go ahead and get started to keep us on track. My name is Katie Sponberger, and I am the Executive Director of the Georgia Association of Conservation Districts, and we are partnering with the Cobb and Fulton County Soil and Water Conservation Districts to bring you the Georgia Conservation Assistance Program, or GCAP for short. GCAP will be providing funding for the installation of green infrastructure practices on residential properties in Fulton and Cobb counties. So we are excited to have the University of Georgia partnering with us on our workshop today. They will be discussing more about the importance of green infrastructure in stormwater management. So thank you, Dr. Gary Hawkins, Martin Wonderly, and Rolando Orellana. We also have several representatives from the two soil and water conservation districts joining us today. Stan Kirk, Alan Toney, and Corey Rayburn. And Corey is also with the City of Atlanta Department of Watershed Management. So just a few housekeeping items before we begin. So all participants in this webinar will be muted during the entire session. If you have a question, you will see a Q&A box on the bottom toolbar of your Zoom screen, so you can type your question directly into that box. A moderator will either reply to your question directly through the box, or we will save your question to be answered live at the end of the program. And if you have a private matter you want to send us a chat about, you can use the chat box, which is also found on the bottom toolbar of your screen. If you're having problems hearing the audio, you can try switching your audio settings to switch to phone audio, and that should clear up your issues there. So today's agenda will be an overview of the GCAP program to start, and then I'm going to hand the program off to the University of Georgia, and they are going to talk more about green infrastructure and stormwater management. They'll also review the practices that will be funded through GCAP, the maintenance of those practices, and then using the water you collect from the practices. And then I will close out the program going into more specifics regarding the GCAP program and the application period. And then lastly, we will have our question and answer portion. So the Georgia Association of Conservation Districts represents all 40 of Georgia's soil and water conservation districts, and we have received the funding to implement the GCAP program from the United States Department of Agriculture. And we are working with the Fulton County and the Cobb County Soil and Water Conservation Districts to implement this program. So every county in the state of Georgia is a member of a local soil and water conservation district, and districts are important because they implement the Georgia Erosion and Sediment Control Act, and they also do a lot of community outreach to promote natural resource conservation. And we do hope to one day be able to expand the GCAP program to other urban areas of the state, but right now it is only available in Cobb and Fulton County. So now I'm just going to give you a brief overview of the GCAP program. So GCAP will be providing funding for the installation of green infrastructure practices on residential properties in Cobb and Fulton counties. And these green infrastructure practices are important because they capture stormwater runoff after a rain event. And properly managed stormwater can protect your property and also streams from erosion. And the best management practices we are funding through GCAP include rain gardens, cisterns, dry wells, downspout disconnects, and impervious surface removal. So it is important to note that we are only funding the installation of these practices, so the homeowner will be responsible for all the maintenance. Trees Atlanta, which is a nonprofit organization, will be doing the site assessments and also will be performing the installations for us. And lastly, any participant that attends this entire hour-and-a-half virtual workshop that applies for GCAP funding will receive some extra points on their application for attending today. And there are GCAP resources available on our website at www.gacd.us/GCAP. Here you will find the online and printable version of the application. There's also our GCAP manual, and the presentation from today will be posted there as well. So now I'm going to turn the program over to Alan Toney, who is chair of the Fulton County Soil and Water Conservation District, and he's going to talk to you a little bit about the importance of green infrastructure in stormwater management.
Hello, everyone. My name is Alan Toney. I am chair of the Fulton County Soil and Water Conservation District. Our district is absolutely the most populous district in Georgia, and I'm sure we have the most impervious surfaces. I'm really proud to be part of this program. We've got some really talented people putting it together, and it's nice to be associated with them. The slide you're looking at is, I believe, Peachtree Creek in 2008 or 2009 when we had the big flood, 500-year event. It should be about 18 feet to the water there, but the water is over the bridge. So that sort of thing happens regularly on Peachtree Creek, but it's not a whole lot worse than it was when I was a boy. And I think that is attributed to the stormwater things we put in place to try to mitigate when it rains. I do a lot of stream sampling for Georgia Adopt a Stream and the Chattahoochee River Keeper. And it's very interesting to me to watch a stream that is clear and beautiful that you could swim and fish in, go to an open sewer almost overnight when it starts raining and we get flooding like this. So the importance of taking care of stormwater is absolutely imperative. I probably don't have to remind all of you this, but when you have soil suspended as silt in the water, it makes the water heavier, it makes it more abrasive, it makes it more destructive in a flood, and it also, the particles carry pathogens. So keeping the soil on the land and out of the water is an important part of stormwater, as well as controlling the stormwater. Our district has 3 river watersheds, which include the Chattahoochee, Flint, Apalachicola, and the Etowah, Coosa, Alabama, which goes into Mobile Bay, as well as the South River, Oconee, Ogeechee, and Altamaha that goes into Darien, Georgia, and the Golden Isles. So all these areas, that's a lot of land is impacted by what we do here.
So welcome everybody, and thanks Alan for that. And like Katie said and Alan said, working through the districts are different ways to help protect stormwater and help reduce some of this water running down into our creeks and rivers. So Katie and them have asked me to go through a little bit about what stormwater is and how it affects what we do on our land, and then how that land actions affect the water. So just to start off, stormwater is, and one group defines them as surface water in abnormal quantity resulting from heavy falls of rain and snow. So as you know, when we get these heavy, intense rains, these days, there's a little bit more intensity to those heavy rains. That water that runs off the land into the stormwater drain you see there on the left, or there in the middle, and then gets down into our creeks and river system, that stormwater can carry that soil that Alan talked about. It can carry some pesticides, it carries nutrients, and we'll talk a little bit more about that. And this water is that water that doesn't soak into the ground. So it's that water that runs off the land, gets into our, as we call it, gray infrastructure, and then down to our creeks and river streams, like Alan mentioned. So where does this stormwater exist? A couple of years ago, we went, my family went and met some of our friends up in Virginia, and we went out to the Jamestown settlement. And as we were walking around, they have replicas of the old Native American huts and the way they cook their food and things. And I noticed the stormwater drain there. And I told my family, I said, look here, look at the stormwater drain. And they practiced this way back in Jamestown era. And my family goes, no, you're not going to take a picture of this. But I'm just kidding, guys. This is not where stormwater started. Stormwater started a lot later than this. But it's just kind of a picture that shows even when we have land running off and water running off the land, we have to manage that stormwater. But really seriously, guys, when we start talking about land use and water movement, the 4 different pictures here from the NEMO group shows that when we have natural occurrences, natural land mass, there on the far left, we have 0 to 5% of that is impervious surface. Now, that impervious surface in natural could be from compacted areas and such as that. When we move to more rural area, we've got 0 to 15%. As you see there, this could be some of those houses. This could be those rural houses out there, and I'll show a picture on the next slide of what that might look like. When we move there to the third picture, suburban areas, we start to get more houses, a little bit more compacted, if you want to call it that, together. And then we get a lot more roadways, sidewalks, and that roof line. So we're starting to bump up to 5 to 65% of impervious surfaces there. When we get to a quote unquote purely urban area there on the far right, we're getting up with a lot of asphalt, a lot of concrete, a lot of buildings. And as you see, we can get upwards to 95% impervious surface. So another picture, and this one was put out by EPA a couple years ago, that if you look at this upper left-hand corner, the natural ground cover, when we get rain on that natural system, only about 10% of that runs off. We do have the grass, we do have the trees, as you see there. And depending on the amount of rain and the amount of water that has infiltrated prior to that rain event, we do still get runoff from those lands, which is not a bad thing. You say we got a lot of evapotranspiration, and a lot of that water, 50% of it, then goes down into the ground. That then helps feed what we call base flow to our creeks and rivers. As you move to the right, we get a little bit more impervious surface. So again, that's these rural houses, as you see out in the quote unquote countryside. Again, we're starting to get that impervious surface, but still most of that water will infiltrate, and we get a little bit more runoff from that. And then just moving then to the far right-hand bottom corner there, when we get in that urban setting, a lot of that water will run off, as you would expect from concrete and that asphalt. And if you've ever been to a large parking lot, when it rains, you see all that water moving down to the stormwater drain. So as we start to develop these areas, going from natural to urban, we start to see some of those impacts of this development. So tree canopy and topsoil removed, as you would expect. We get those compacted soils. So now we're starting to build houses, we're starting to build businesses, we're starting to build roads. And when we start building those roads, houses, parking lots, we have to compact that soil so that the top layer, the house that's sitting on it, the concrete, the asphalt, has a good base. So we're starting to get that compacted soils. We get that impervious surface, and when we do, as you know, water does not infiltrate through concrete or asphalt very much, especially shingles on our house or the tin roofs. It doesn't come into the house. So that impervious surface doesn't allow that infiltration of water, so it has to run off. Once we start to get that runoff in this right-hand picture, you start to see it runs down and concentrates that flow in those stormwater drains. And that stormwater drain then typically will have, as you see there on that right-hand picture, a pipe that runs down to our creeks and rivers. If we get enough flooding, if it's been a lot of rain prior to the day that it rains, I know when I watch the news out of Atlanta, especially if it's rained for 2 or 3 days, they say there's a possibility of those flash flooding events, and that's why the ground is saturated. The water can't go in faster than it's coming down, and it runs off. And then that picture there in the bottom middle is an indication of this stream has gotten a lot of flash floods, gotten a lot of high water coming down it, and you see the erosion occurring there. So why then do we want to manage stormwater, and why do we want to start looking at green infrastructure? Alan mentioned it a little bit. We want to cut down on the sediment. We want to cut down on the pathogens. We want to cut down on the pollutants moving into our creeks and river streams. But one of the other things we want to do is we want to mimic that natural hydrology. So we want as much of that water to go into the ground surface. We want it to go in so it, like I said earlier, it infiltrates and it can help feed that base flow onto our creeks and rivers around Atlanta area, around the suburbs of Atlanta. It also reduces that pollutants entering those local waterways. So these are the nutrients, the fertilizer we put out, the sediment, that's the soil from construction sites, from our yards, and the other pollutants that may be out there. I mean, how many times have you ridden down the road and seen cups and paper bags and grocery bags and things laying in the roadway? When it rains, those things go down to the stormwater drain, gets into the creeks and rivers. So those pollutants, some of the other things that I talk to a lot about when I talk with groups is grass clippings. So if you put your grass clippings on the street side of the curb, when it rains, those grass clippings, leaves or whatnot, gets into that stormwater drain as well. When we look at green infrastructure, like I said earlier, it increases that infiltration. So we want to get water into the ground again. So we have to use less irrigation water, but also to mimic that natural hydrology of getting that water in the ground. On the previous slide, we talked about protecting creeks, streams, and rivers from flooding. So again, the less water we have run off the surface, the less we have to transmit to those creeks and river systems. And the creeks and rivers then can do their job of moving the water that's naturally there off of the land surface and away from the land surface without having this extra water from impervious surfaces. And then, as you'll see with the rain gardens and some of those pictures that Martin will show and then Rolando will show in a little bit, it enhances that aesthetics of our communities. So today, Martin's going to go through a lot of, not a lot, actually 5 different practices that Katie talked about through the GCAP program. One of those will be rain gardens. So Martin will explain a lot about what rain gardens are, where we can put them, how do we use them, and such as that. The other thing is he'll talk about impervious surface removal. So this is a road actually in front of my house. They paved it or repaved it last week. So when we start pulling this pavement up, I mentioned earlier we have to compress and compact that soil prior to putting that pavement down. So removing that impervious surface, we have to then deal with some of those issues after the fact. And again, Martin will talk a little bit about that. Downspout disconnect, as you see the pictures here, we remove that downspout from going into the stormwater drain and let that water move out onto the soil surface. Dry wells is another way to kind of take care of that water. Again, it's really just getting that water into the subsurface and infiltrating it out and about versus going into our stormwater drains. And then cisterns, rain garden or rain barrels, big cisterns. And again, we'll talk about that. And then Rolando will talk about how we can use some of that water. So with that, I'm going to stop sharing now. And Martin, I'll turn it over to you.
Okay, thanks, Dr. Hawkins. And thank you, everybody, for joining us today for this workshop. As Dr. Hawkins said, I'm just going to run through these 5 different green infrastructure practices that can be funded by the GCAP program. I'm going to explain just what they do and where you might put them and a few other considerations you might think about before choosing a practice. And then I'll turn it back over to Dr. Hawkins, and he'll get into some of the engineering and maintenance requirements for these practices. First of all, we have rain gardens. These are vegetated temporary retention basins for capturing stormwater runoff or infiltration into the ground that should happen within 48 hours after a rain event. These are low maintenance, they use little water, and they're beautiful landscape features. They reduce the stormwater runoff and pollution from your property. Also reduces flood risks and damage downhill and reduces pollution downstream. All this runoff is eventually making it into our waterways, so we want to reduce this pollution. Rain gardens can provide a different type of habitat in your landscape, and they will not increase the mosquito numbers. Remember, this water after a rain event drains out within 48 hours, so not enough time for mosquitoes to live there. You will attract all types of nice birds and frogs and turtles, though. This picture is during a rain event. That's why it looks a little gray, and there is water in this rain garden. This one is just an example of a nice design. If you like the dry creek bed look, you can do something like this with your rain garden. You want to locate your rain gardens to receive maximum amount of stormwater runoff from impervious surfaces like your sidewalks and driveways, and also from your downspouts, which are sending stormwater from your impervious rooftop. You may need to redesign some of your topography with swales and berms, and also point your downspouts and your extensions to help route this stormwater into the rain garden. They should not be within 10 feet of your building foundation, and they should not be in the public right-of-way, and you should avoid utility lines and septic fields and any steep bluff edges on your property. And make sure your contractor or construction company is called 811 before digging to avoid utility lines. Here's another photo of a typical rain garden design in the backyard. So we're moving on to impervious surface removal. It's exactly how it sounds. We're getting rid of impervious surfaces. This will increase the infiltration of rainwater, stormwater into the ground instead of running off. So it reduces the stormwater runoff from your property. This provides aesthetic benefits, also known as beautification. And just remember to keep your erosion and sediment control measures in place before you establish new vegetation on that bare land. These erosion and sediment control measures are silt fences and hay bales, or hay wattles, they're called. And Dr. Hawkins is going to get a little bit into what you might replace these impervious surfaces with. And I think the GCAP program, as will be explained later by Katie, will cover what GCAP can fund in these locations. Next few slides, I have a few pictures of just what to think about. If your property looks like the one on the left, you're creating a lot of stormwater runoff. And it's not the same house, but the property on the right is just an example of what you could have. And instead of impervious surface, you could have a nice landscaped area with trees and flowers. Similar here, we have the house on the left, that somebody might need to do a large impervious area for a turnaround, but just if you think minimizing impervious surfaces, you should think about the house on the right. You can still get your turnaround, your parking spaces, but you've reduced your impervious surface probably by 50% there with a nice landscaped circle in the middle. Moving on to downspout disconnects. Downspouts that are directed to driveways cause stormwater flooding and runoff pollution. You can see in this picture the rainwater is going to go right down the driveway and right into the street and downhill. Some houses also have downspouts that are connected underground with pipes to local storm drains or sewers. So when it rains, 2 inches in an hour in a thunderstorm, all of that rainwater is being contributed to storm drains and sometimes combined sewer systems, and that's not a good thing for the downstream water quality. So we want to break this direct connection between your downspout and storm drains, and we want to allow this stormwater to infiltrate into the ground. And as I mentioned, some of these downspouts are connected, as you can see on the drawing, underground to the stormwater system. And when you disconnect your downspout, you'll need to cap the riser pipe that leads to that underground plumbing to the storm drain. You're no longer sending the rainwater off your roof into that storm drain. We're extending the downspout out onto a pervious landscape, such as your lawn or other landscape feature. This photo is another example of a downspout that is directly impacting stormwater runoff. It just opens up onto the sidewalk, traveling through a pipe under the lawn. So we want to disconnect these downspouts and help prevent stormwater from overloading our storm drains, flooding neighborhoods, and contaminating local rivers, lakes, and streams. Now, this is where we would prefer that we send our stormwater runoff off of our roof through an extended downspout into a landscaped area for infiltration into the ground. You can also divert this stormwater into another green infrastructure practice, such as a dry well or a cistern or a rain garden. So we're connecting some of these practices. Now, first of all, dry wells, they're basically an excavation in the ground with an empty perforated chamber in it that temporarily stores stormwater until it infiltrates into the soil below. You can see in this picture that final product, they'll recover that with soil and earth and landscaping. But that will be connected to probably a downspout as you go further up that little channel that was dug into the ground. Have a direct connection to that dry well to collect stormwater. You can have different sizes for different applications here. And dry wells can be directly connected to your downspout. You can collect runoff from parking areas as well. You can direct that into your dry well. Just remember that we do not want to put the dry well under an impervious surface in case you need to work on it. And we want that to be at least 2 feet above a water table underneath your dry well. You do not want to put these over utility lines or above a septic field. But this photo shows an area that probably could use a dry well to the left in the landscaped area where it can collect this stormwater. Now, cisterns are a little bit different. They're just usually above ground, and what they're doing is harvesting rainwater for another use. Instead of infiltrating it into the ground, we're collecting it in some type of containment system. You can see the photo here. It's a large container with all the downspouts heading to it. This is collecting the rain from our rooftop, and it provides a significant reduction in stormwater runoff and pollutant loads that leave residential properties. There are a few measures you should include so you don't end up clogging up your cistern with leaves and other matter. You see a few screens on this slide here that are just meant to keep leaves and sticks and other debris from entering your rainwater collection cistern. And I think Dr. Hawkins will explain a few other pieces of engineering that will help prevent from contaminating your rainwater source. So these cisterns can be different sizes. This is just a photo of a 55-gallon rain barrel, but they can be large enough to hold 1,500 gallons. So you can use this water for irrigation on your property. And Orlando or Alana will explain some of the irrigation concepts with collected stormwater later on in this presentation. You can divert the overflow if your rain barrel or your cistern is filled up. You can divert the overflow to another stormwater green infrastructure practice, such as a rain garden. Here's another photo of a cistern. Some things you should keep in mind when choosing location. Make it easy to connect to your roof drains. You don't want to put it halfway across the property, so you're running your downspouts all the way across your property. You need an overflow area that will go down slope from your cistern. If it does fill up, where are you going to overflow to? Your cistern should be on level ground, and think about where you might intend to use this harvested stormwater when you choose a location. say you have a flower bed that you need to water regularly. You want to avoid utility conflicts, electrical connections. If you need to pump the water out for your irrigation, you might need to consider where your electricity supply is. And you don't want to block a window that's used for emergency exit from your building. And think about location of hoses and other distribution parts for your irrigation system. And think about where it just might look nice for aesthetic considerations. And I think I'm going to hand it over back to Dr. Hawkins here to talk about maintenance.
Thanks, Martin. Let's see if I can get the screen here. So Martin went through the 5 practices that the GCAP program will cover. And then, so what I want to do is just go through a little bit of the maintenance side of it. And again, Katie mentioned it earlier that GCAP doesn't pay for the maintenance, but once you get one of these practices installed, or if you have one installed, here's some of the maintenance ideas that you need to think of. Now, I'm not saying this is an extensive list, but these are some of the things that should be considered when you start looking at these practices. So if we're talking about rain gardens, the best thing is to reduce and eliminate sediment from entering that rain garden. So for instance, here on this lawn, if for some reason this was a bare lawn above, if you want to call that above the rain garden, then put maybe something there to slow that water down, let it settle, let the sediment settle out first before the water and the sediment gets into the rain garden. Keeping sediment or allowing sediment to get in there will actually what they call blind potentially the rain garden, and you get a pond versus an infiltrating rain garden. Next thing is make sure you keep healthy plants in there. So the plants do a couple different things for us in rain gardens. One, they look nice. They attract the pollinators. But what they also do is they evapotranspirate. They move a lot of that water back into the atmosphere for us. So keeping a healthy plant population in there gets a lot of that water back into the atmosphere for us. And again, keeps it from running off further down the line. If the rain garden then starts to hold water, there's a couple things we can look at. Or is there a lot of sediment getting into that rain garden? Is there a lot of litter buildup? So if you've got, like Martin talked about, downspouts or some other methods of water feeding into that, are you getting a lot of litter? Are you getting a lot of leaves? Around my house, crepe myrtle balls or seeds. So are there things that go in there that as they break down form an organic layer that potentially could be restricting water flowing down through the median down into the ground? So if you notice, the rain garden is actually holding water longer than that 48 hours or so that Martin mentioned, maybe go out there and quote unquote dig around a little bit in the rain garden to make sure that you don't have a sediment buildup issues. And like I said, there could be other causes. This isn't an extensive list, but if the rain garden isn't getting rid of that water within that 48 hours or so, start really looking at it as to why water may not be infiltrating. When we start talking about impervious surface removal, the biggest thing here is if you're going to remove that asphalt or that concrete, what's the next steps? What are you going to do to replace that, or what are you going to put in the place of it? If you're going to make it a rain garden area, for instance, then you might want to test the soil because the soil has been compacted. If any of this organics has leached through, for instance, this asphalt, you may need to bring the pH up or bring the pH down. So start thinking about, once you remove that concrete or that asphalt, what's going to go in this place? If you're putting back some other kind of walkway that's pervious, then again, what's that base, and is that base proper for that new GI infrastructure that you're putting in? When I was talking about downspout disconnects, then again, Martin mentioned, how we can get that water to rain gardens or other GI LID practices, but we need to look at how do we reduce the water from flowing onto those really highly erodible spots. So if you disconnect that downspout, don't let that water go out onto a bare area. That bare area with the velocity of the water coming through that downspout can erode that soil away. So just kind of be mindful of where that downspout goes to. You see here in the left-hand picture a splash guard, so that reduces that flow velocity just a little bit. On the right, it actually goes into a flower bed or a rain garden along with that pipe. And then the next thing is, if we need to move that downspout, can we move it to different parts of that area so that we don't get one area that's really wet and causes other problems. One thing you need to look at and think about then too is locate and address any channelized areas. So if we start to get a lot of water coming off of the roof areas and start to see channelization, again, move that downspout if possible, but then really address those channelized areas, because if we get them before they really get deep, then we can maintain them a little bit better. With dry wells, as Martin said, a lot of the water will go in here. And I noticed in the chat that one of the things that Corey mentioned was the dry wells receive that first inch of water. They don't really take up a lot of the bigger storms, but those things are designed to take up just a certain amount of water coming off of that roof. But if we fill up that dry well with leaf litter, with other debris, then it can't handle that volume that it's designed to do. So keeping that leaf litter out, and I'll show a first flush diverter here in a minute. And Martin mentioned the leaf guard or the inline leaf litters. And what those things do is they keep those leaves, those crepe myrtle seeds and things out of the dry well or the cistern, and lets mainly just water go into those systems. You need to watch the level in these dry wells as well. Just like the rain gardens, if we get a lot of sediment for some reason building up in the bottom, and the way these dry wells work is you get exfiltration, or you get movement of water out of these containers into the surrounding soil and the soil below it. If we get a lot of sediment in there, it can actually blind the system, so it can't hold as much water as it was designed to. So just kind of keeping a watch on that level. Again, if we know it's supposed to move the water out in a certain amount of time, if you get one and you have one and it's holding water longer than that specified amount of time, there's something we need to kind of look at as to why is it not moving that water out. And again, keep those first flush diverters clean and maintained to keep relatively clean water going into these systems. When we talk about cisterns, then again, the picture here is a first flush diverter. And what you can see here is it has a hose bib on the bottom or a spigot on the bottom, has a clean out plug on the bottom as well. And then about 2/3 of the way up, you see that floating ball. So the way this works is when that first flush of water comes through, with a lot of the debris in it and such as that, it will go down into that standpipe below what you have here is the outlet. It'll catch all that material. Once it fills up, that floating ball will actually blind off that water, and then all the water thereafter will go into the outlet, if that's a cistern, if that's a rain garden, or if that's another form of whatever. And then every once in a while, you need to go drain or open that hose bib or take that clean out plug out just to get all that debris out of the system. Martin showed a picture of the inline leaf litter, the same thing. Make sure that leaf litter is clean. The way it works is the leaf litter will go on that screen and go off and away from the house or away from the downspout where the water will go through, but just making sure it's clean and not being blinded. With the cisterns as well, the biggest thing you need to do is look at having a dark tank. Some of the pictures, or the pictures, I guess, that Martin showed was a green tank and a black tank. You definitely don't want a tank where light can get into it. The purpose of that is that it's the lighter tanks, the opaque tanks, the clear tanks will allow algae to grow faster than a dark tank. And typically the dark tanks, you don't have very much, if any, algae growing, which then can cause problems within the tank. with some of the stuff Rolando will talk about or otherwise. So having a dark tank is preferable. Between rain events, then you need to remove as much of that water as possible, because the cisterns are designed to hold a specific amount of water. If you don't get that water out between rain events, then obviously it can't hold any more water. So that's one of the big maintenance issues with cisterns, is getting that water out. And if you need to use it for irrigation, make sure it's not on editable crops. If it is, you really need to check that water quality. And I know Rolando is going to talk a lot more about water quality here in the next couple of slides. So with that, I think, Rolando, I'll turn it over to you and let you go from there.
Thank you, Gary. So,
you're welcome.
Dr. Hawkins mentioned, my name is Rolando. I work for the Center for Urban Ag in Griffin, and we will talk today about alternative use of the water that is being captured and the different cisterns and rain garden water uses. So obviously, you probably already know that the system, the roof water catchment systems are being used in so many different places of rural America and other different countries to use water because they don't have any alternative water sources. So this is new. It's not a new concept. The Greeks used to use it. The Romans, parts of the Asia, and the different parts of Asian countries and Asian region were used before they even have any knowledge of what the system that were used by the Western civilization. So it's very practical. It is very practical in areas where we have a lot of, good precipitation average. In some areas, it's probably not very practical because they don't have good average. But locally here in Cobb County and Fulton County, there is a distribution supply, and it's very efficient, and it is available to residents of the two counties. And in the state of Georgia, the water in Atlanta, the metro city, is considered one of the most expensive waters there is in the state. So Cobb County is a little more affordable, but it's still somewhat affordable, if that serves as some kind of joke. But so what is the use that we're going to use? We have already these systems, and if you guys were working with the GCAP program to make some improvements, if some of those improvements will be install cisterns or these water tanks to capture that water, there is some few you can have. Obviously, it has to be a non-potable usage for irrigations and other uses that, it won't intend, consumption for humans. Obviously, those large tanks, we have to know how big they are, how much water those tanks will hold, where are they located, and then so it can be utilized either for lawn ornamentals and tree irrigation, or even raised beds for gardens use, etc. The cistern, so the tank, it can be underground or above ground. You're going to use it above ground if you need to have some kind of pressure in case utilizing a lawn pump. But if you have one underground cistern, there is a few things that you need to have, as you can see here in the slides. You need to have a pump and all these electrical lines, float switch. This got stuck here. So one of the things that we need to understand, the tank needs to be located where the area that we're going to be using it. It has to have enough capacity so it can hold enough water to water the area or the plants or the trees or the raised bed that we're gonna be watering. Obviously, you need to be able to have a pump that will be capable to provide the pressures needed for the irrigation system that you plan to implement in the area. Obviously, those pumps have a cleaning, filtering, leaves, debris before that water can be utilized, because it might probably not give you the pressure that you need. Obviously, if we have one of those tanks, we need to be able to understand how much lawn are we intending to irrigate. Most lawns, or the average lawns, I will say, go from 1,000 square feet to 3,000 in the front yard, and even more in backyards. So you won't need a lot of water for that. So you probably need to decide what area you want to be watering. So probably you start with a good measure, 1,000, 2,000, 3,000 square feet. Obviously, the lawn or the type of grass you're going to be using has a specific water requirements. We have so many different type of grasses available right now. So even though when some of them, we might look similar on the water requirements, some type of grasses require less water, and that will be very helpful for the system you want to install in for water conservation purposes. Obviously, the type of soil we have here in Georgia, very much of red clay, which is bad for water infiltration. And the terrain, how much slopes you have, that's going to cause a lot of water runoff. So those are the things that we need to consider when we will be doing or installing or utilizing this water. Amendments that includes maybe incorporation of some organic matter that can be before we start using this type of system, so we can have some water conservation. Obviously, the pressure will be playing a big role with this irrigation system that we're going to be installing for water the lawn. Like I said, sometimes if you have the underground system, you might need a tank. You might need a pump. But if you have enough pressure from a above water tank, you might do well with that. But that's something you might look into and something to consider. Obviously, type of grass will play a big role on this. Some type of grasses use less water than others. This is how a portable lawn pump looks like. You can see, you can get those in some of the big box stores or garden stores. They will range between $150 to $300, give or take. So they're easy to install, and they will provide the pressure that you need for the system you want to install. Just a quick, I wanted to talk a little bit about the grass that a UGA engineer that it was released a few years ago. I don't know if you've been familiar with this, but this is Tiftoff. Tiftoff have been tested in around 19 drought stress trials to sport fields. So different universities try these things, and they found out that it saves around 38% of water compared with Tifway. So I think this is a good option if somebody who wants to be doing or implementing. So 38% less water compared to Tifway. So this is a pretty good option for somebody who wants to implement some of these practices. When we're talking about irrigation on trees as ornamentals, obviously we're not going to be using the sprinkler systems. We're going to be using something, the drip system, which it will provide or doesn't need a lot of pressure, and obviously will have or need some type of maintenance. The initial cost of this is going to be depend, how much or how or quality you want to add to the system, but it will definitely cost some at initial. It is most effective because you're going to be delivering the water where it is needed. Obviously, you want to be minimizing the loss of water by evapotranspiration, which is one of the problems that we have, and obviously for runoff. Mulch provide this layer so you can conserve some moisture and not lose some of that water by ET. But drip irrigation systems will be very ideal for trees, especially for trees that need to be established within the first 90 to 150 days. It is critical to have that water that they need to be able to establish. Same thing with ornamentals. That's one of the critical part. Most of those plants die in the first stages of their establishment because they have lack of water or excessive water. Water use of this water on raised beds or gardens. This is very important to consider that this water quality needs to be tested to be able to be utilized or be able to use this on raised bed for vegetables and for human consumption. So one of the things that you need to do is reach out to your local extension agents to help you to decide what type of testing you will do at the UGA water lab. And this is some of the publications you can get at the College of Agriculture and Environmental Science website. There's a number of publications. There's hundreds of publications over there. And one of the faculty available over there will be Uttam Saha and some others that will be able to help you. Obviously, to get to them, you need to be, contacting your local extension office. You can see Melissa Matee in Fulton County South. North Fulton will be Carol Stringer and Hallie Harriman in Cobb County. So they will be your local point of contact over there, so you can get access to this water testing. And they will explain you some more about the gardening part and also for the water testing. Just to talk a little bit about rain garden, obviously all the plants that will be planted in some of these rain gardens will need water to establish. We need to get them established and we have enough water. Sometimes these plants will need some water when there's deficits on drought, depending on the years. Now weather is so unpredictable, and sometimes we got so much water, we have some deficit sometimes. So it is it varies very often. Obviously, native plants will be very most of the times will be very tough on drought resistance, but most of the times native plants need to be good on flood or water, too much water tolerance, because a lot of those rain gardens get water standing around and waiting for the infiltration. So that might need to be plants that it will be tolerant to that. Just quick, the overview of some of the plants that might be available for this type of rain gardens. I wanted to put this tree over there. Trees are very beautiful, different, good colors, and they enhance the view of the landscape or areas or yards and residential areas. So this is the Southern Sugar Maple. It is available and is recommended according to the City of Atlanta list that you will find on the GCAP annual. It's very attractive. You can see this, how beautiful it looks. So it might be a good option. Then you have the Southern Wax Myrtle. It's a tough, fast-growing evergreen. This shrub is covered in beautiful dusty blueberries in the autumn. It tolerates a variety of soil from sand to clay. It grows in areas with low fertility. So that will be a good quality you might going to need. It is unattractive to deer. I know in some parts of the, Fulton County and Cobb County, that is a good quality that is very desirable. Monkey grass, this is there's very used in the landscape in the metro area. Other names include liriop, spidergrass, lily, bordergrass, and mandelgrass. It's not an actual grass; it's a perennial with leaves that resemble grass. That's one of the things that you can see. It has some nice color, different colors in this time. In this case, you can see this purple, beautiful color. And then we have the butterfly weed, which is normally grows on dry habitats. It is a perennial. Wildflowers does not transplant, so it has the deep woody taproot. It's easily propagated from seeds. So you can get some seeds, and you can easily establish a nice plants of butterfly weeds. Then you have the ferns. The American Royal ferns is typically grow in clumps of 2-3 inches feet tall. So it can get really big, up to 6 feet high when it has a lot of water or moisture available. And it's a good selection for wet areas like ponds, streams, rivers, and gardens, etc. So this all I have for today. I want to turn over it back to Katie, so she's gonna talk about some specific about the applications and timelines of the program. Thank you.
Thank you, Rolando. Okay, so this is Katie, and I just want to thank Rolando, Dr. Hawkins, and Martin for their wonderful and informative presentation. Hopefully, if you don't decide to apply for GCAP, or if you don't receive the funding, you will maybe implement some of these practices on your own property in the future. So now I am just going to review the GCAP application and timeline period for funding. So the application period opens today, and it will go through the end of this month, and the online application is available at our website, www.gacd.us/GCAP, and we also have a printable version available online as well that you can print off complete and mail in or email in to us. And as we've discussed today, the best management practices eligible for funding are rain gardens, cisterns, dry wells, downspout disconnects, and impervious surface removal. So the funding is for the installation of these practices only. We will not be providing any funding for the maintenance of the practices. So that will be the responsibility of the homeowner. And once Trees Atlanta comes out and does the site assessment of the recipients, at that time you will know which practices that are deemed necessary for your property. And the site assessment may say that you need one or a combination of these practices for your property. So there are some requirements to apply for GCAP. So the property must be a single-family residential property located in Cobb or Fulton County. The homeowner must sign off on the application. So if you are a renter, you are welcome to apply. And if you are chosen for funding, then there is a waiver that we would need the homeowner to complete. Also, the homeowner must clear all the BMPs with their HOA before the installation. And then land that is currently enrolled in a cost share program, such as one with the United States Department of Agriculture, is not eligible for participation. So all of the applications will be reviewed and ranked based on factors including financial need, need for services, and also if the property is located in an impaired watershed. And here is just a link to a map where you can actually look at all of the impaired watersheds in your area. So the funding timeline, so application period will be open from September 10th through 30th, and GACD and the 2 conservation districts will review and score the applications. So we expect the application scoring to be complete by early October. So at that point, we will notify the applicants and let them know they are moving on to the second phase of the application procedure, which will be a site assessment by Trees Atlanta. So they'll visit the property and determine the BMPs needed to best fit the property and the homeowner's needs. So once that site assessment is complete, GACD and the conservation districts will notify the funding recipients, and then the recipients will work directly with Trees Atlanta to schedule their installations anytime between fall of this year and spring of next. And I just want to note that GACD will be paying Trees Atlanta directly for the installations of these practices. So we will have a wait list. So after the initial funding period closes, those strong applicants that could not be funded in the first round will be notified that they are on the wait list for the second round of funding. And that second round of funding will begin in spring 2021. So now I am going to ask my colleague, Katie, to present some of our questions from earlier, and we'll get those answered for you all.